Hello everyone. In this video, we are going to cover an example on extendable hashing. So in our example, we are going to insert all these records into our extendable hash. And let's say that we are going to hash the records on the department name attribute, right? And also assume that you have a hash function. The details of that hash function is not really important for studying this topic. Let's assume that you have a hash function, and for all the department names which are going to appear in your data set, let's say that these are the hash values which are generated by your hash function. And in extendable hash, we are going to insert these records while hashing the records on the department name attribute. Okay, so let's see how that goes. Okay, so we'll start with an empty file, and as I said before, I'm going to assume that one bucket is basically one disk block, and one disk block can store two records. Okay, so we'll start with an empty file where your bucket address table is basically null, the global depth is 0. And so what that means is that whatever records that come at this stage will be just going to bucket number 1 irrespective of the hash prefix, right? So let's say the first record is computer science record, and I think this is the hash value of that. And so given that global depth is 0, so essentially I do not check any prefix and I simply send it to bucket number 1, right? So that's there. Then next, I think I have this particular record from the music department, and again, as I said, global depth is 0, so we don't check for any hash prefix and we simply send the record to the bucket number 1. Okay, so far straightforward. Okay, now it's interesting. Now you have the third record coming from the finance department, right? Now, as per your existing extendable hash, this record will also be tried to, we'll try to push it into bucket number 1, but it cannot be because the bucket is already full, right? Now the splitting starts. So this is the case of an overflow in a bucket whose local depth is equal to the global depth. So local depth is 0, global depth is also 0, right? And the 0, it's basically meaning that we are simply not considering any prefix. Whatever record is coming, we are just putting in this bucket, right? So nevertheless, this overflow is still a case of local depth equal to the global depth, right? So what I do is first thing is that I'll increase the bucket address table size, right? So initially it was just one entry pointing here, and global depth was 0. So from global depth 0, I'll make it global depth 1, right? So that means my hash prefix, I'm going to use 1 bit of hash prefix, and that 1 bit can either be 0 or it can be 1. That's the only possibility. And first, when I double this bucket address table, I make both the entries point to the old bucket where originally it was pointing. Okay, so initially I had only just one bucket, so therefore out of nothing I got two children, 0 and 1, and they both are going to point to the same old bucket, right? Now global depth is 1. That means I am capable of taking 1 bit from the leftmost two disambiguate records, right? But I have only one bucket whose global depth is 0. That means it is not taking any bits to disambiguate the records coming to it. Now in this case, we'll again we'll attempt to insert finance record, this particular record into this, right? It will still be an overflow, but this will be the overflow of the kind of the first category, where I am having an overflow in the bucket whose local depth is less than the global depth, right? Okay, That is this case. Okay, so I re-attempt to insert the finance department record. It would be an overflow with local depth less than the global depth. Now let us see how that works out. Right, so as per our procedure, what did we do? Whenever we had an overflow in a bucket with local depth less than global depth, we always created one new bucket, and half the entries started pointing to the new bucket, and the local depth was increased by 1 unit. So originally the local depth was 0, now the local depth is going to be 1. Now in this stage, we are going to rehash all the records, the earlier ones which were sitting in this bucket and the new record which has just come. Right. So when you rehash this, I think this will be the case. Right. So music, I think had 0 in the leftmost, so therefore it stays here. But at the computer science, I think it had 1 in the leftmost bit, so it comes here, and the finance record will also go here. Okay, uh, now the key, okay, a word of advice, when you are going through this example, make sure you open and keep this separately somewhere, because the hash values we are going to use from this slide, right? So make sure you open that in a separate window when you are actually studying. Okay, so here this is resolved. Yeah, we are here. Okay, so this will be the end stage or the final stage after we attempt to insert finance record, right? So global bucketed is stable, expanded. Now the global depth is 1. That means I am taking 1 bit of hash prefix, and I have now 2 buckets, and then these are how the records are, right? So here there's an interesting thing to note, and it's more on the implementation side, right? Okay, so in this case, these 2 records were there, and then you had a third record, and then when you rehashed, everything worked out nicely. 1 record stayed here, and then 2 records came here, right? So that was sort of the good case, right? uh, just to show you, right? So it nicely spanned across the 2 buckets, and then there was no further problem. But in worst case, it may happen that all the 3 records happen to have a hash prefix of 1 only. It can happen, very much possible. So then what will happen is that even after you did an expansion, the collision will still not resolve. All the 3 buckets will try to come and fight here, right? So that will again be an overflow, and that will be an overflow of the case where local depth is equal to global depth, and then you have to do the doubling and all that, right? But in implementation, what we do is that it's advisable, and whenever students implement this, I always give this advice, is that after you have attempted to resolve a collision, right? So here, when finance record came in, there was a collision, and then you did some expansion and all that. After it didn't work out, I did not force further expansions, right? That is what I would recommend, right? If all these 3 had a prefix of 1 only, and all these 3 were again coming and fighting here, I would have simply made an overflow bucket here and then put the extra record over there, right? So this is more often from the implementation perspective. This is what we would like to do. Okay, yeah. Now the next record. So physics record with hash value 100 and so forth, right? So where will this go? So I'll come here, I'll check, now my global depth is 1, so I have to check the leftmost bit of the hash value, which is 1 here. So the physics record will come to this bucket, but it is full, right? So again, the second case of overflow, where I'm having an overflow in a bucket where local depth is equal to the global depth, right? So local depth over here 1 is equal to the global depth, right? What do? You have to do directory expansion, and as I said before, in directory expansion, what happens is that each of these bucket addresses, they spawn 2 children. one with suffix 0, the other one with suffix 1. So 0 guy will spawn 00 and 01, and 1, this entry will spawn 10 and 11, right? Now both these entries 00 and 101 will point to the bucket which its parent was pointing. And similarly, these two children 10 and 11 will point to the bucket which the parent of these guys was pointing, right? So parent of this guy was the entry 1, and that guy was pointing to this bucket. So therefore, these two will also continue to point to this bucket. Similar is the case here, right? And after you do this, of course, you have to adjust the local depths immediately, otherwise, it will be wrong. So local depth of these will be 1 only. Why? Because all the entries which are pointing to this bucket, they share only the leftmost bit. All the records which are going to come here will share only the one leftmost bit, and all the records which are going to come here will share only the one bit. So that is why this local depths are 1, whereas the global depth is 2. Now in this case, after you have done this expansion, you again attempt to insert the physics record which actually caused all of this problem, right? So the physics record will come here, and of course it's an overflow, but this is the overflow of the first category, where you are having overflow in a bucket whose local depth is less than the global depth. Now as before, what do? We create a new bucket, we set the local depth of that new bucket and this bucket to 2, and the lower half of the pointers will start to point to the new bucket, and then you rehash these two records and the new record to see where they land, right? That's what it is. So after you do this, I think, yeah, I think this is the end stage, right? Okay, let's go forward. Yeah, I think just one more slide. Okay, so after you inserted the physics record, this is the status, right? So your global depth is now 2. The first two hash prefixes continue to point to the music department with local depth 1, whereas here now you have two buckets with local depths 2, and then after you rehash, this is how it comes out. Okay. Okay, so these two records, they must have a hash prefix of 10. That is why they are here, and the computer science department, I think, has a hash prefix of 11. That's why it came down. Okay, so going forward. Okay, so yeah, so now in this particular stage, I am inserting one record with faculty name Raj, and let's say he's from aeroscience department. And for sake of example, I'm assuming that the hash value of the aerospace department is 010, right? So what will happen is that I'll check this hash prefix, global depth is 2. I'm going to check the first two bits over here from the left side, and the record will just go here. Not a big problem. It's easy so far. Now again, I have another record with, let's say, mechanical department, and the hash value is 011, right? So with global depth equal to 2, this guy will come and try to fit in here in this particular bucket, but that is going to be an overflow. So how do? We create a new bucket, increase the local depth from 1 to 2 for both those buckets, and half of these means this pointer will point to the new bucket, and then you rehash these two and the new one, right? So that's how it ends up. Okay. Okay, I think this is the last entry. So now in this case, I'm inserting a record with faculty name Peter from civil engineering department, and the civil engineering department, the hash value is 100 followed by something. So this particular civil engineering department guy will come here. It's an overflow, but it is an overflow in a bucket where local depth is equal to the global depth. So you have to do the directory split. Now how will the first step look like? Each of these four entries will spawn two children. 00 will spawn children with 000 and then 001. This guy will spawn two children, one with suffix 0 and one with 1, right? So this guy will spawn 010 and 011, and similarly so forth, right? So this is how it will look like. So 00 spawned two children with 0 and 1 as the suffix, and similarly all the entries over here, they spawn two children, and both the children will continue to point to the same old uh, the bucket where its original parent was pointing to, right? So this guy 00, and that guy continues to point to the music department, and then this guy, the children of this guy will continue to point to this Ramesh and Raj bucket. So that part is there, right? And this guy, children of this guy will continue to point to this bucket only, right? So this part was there. I think so. Initially here also, children of 10, these two, 100 and 101, they will also point to the same bucket. But I skipped a step here, because you remember, after that stage you reattempt to insert the new record, and that will be case of an overflow with local depth less than the global depth. So I created a new bucket. So sort of, I skipped a step here, but I hope you understand why this is happening. Okay, make sure you actually work out this entire example, and you should understand everything which is written on these slides, right? If there is any doubt, let me know. There is no magic going on here. So everything is absolutely well defined. Okay, make sure you work out this example through and throughout, right? Yeah, so just setting the local depths, right? So local depth of this guy is going to be 2, because all the entries which are pointing here, they share the left 2 bits, right? Similarly, this guy will also have a local depth 2. This guy will have a local depth 3, because the records which are coming over here will have the same prefix up to 3 bits, whereas here they will have the same prefix up to 2 bits, right? So that's how this local depth thing is there. And as I said before, whenever things are sharing, whenever two prefixes are sharing, you rest assured that the local depth will be less than the global depth. That is another way to self-evaluate your answer. But whereas if your hash prefix is not sharing its bucket with any other prefix, then its local depth will be same as the local depth. It's a simple way to cross-check your answer. Okay, this is another example. This small exercise, right? So if two records come here, what is the end result, right? So I think you should work it out. It's a very important algorithm, right? You should, given a data set and a set of hash values, you should be able to trace out the extendable hash algorithm. It's extremely important, you know that. Okay, so now some closing comments on extendable hashing algorithm, right? So there are some benefits in the sense that as your file grows, the hash file will also grow. There is a flip of what the algorithm I have covered. I'm covering only the splitting algorithm. You can create an analogous compressing algorithm also. It is possible, but that gets too convoluted for a UG course. That's why I didn't cover. And generally, in real world database, you will see growth much more faster, but that's okay. But nevertheless, rest assured that even if things are getting deleted, you still have a way to compress. Just like directory split operation is there, there is also a directory compression operation is there, right? But for this course, we'll just cover only the split one. So there are some disadvantages of extendable hashing, uh, but that's just for the sake of argument. So one being that you have to maintain this bucket address table, right? So that is one extra level of discrete operation. So it may happen that your this bucket address table itself is so long that this may also have to be kept on secondary memory in disk blocks. So these buckets are anyways in the secondary memory. This may also be in secondary memory, and then you may just have some initial maybe few entries in the main memory, and rest half over here maybe sitting in the secondary memory. So whenever that goes, whenever this bucket address table also goes into the secondary memory, you start having more disk read operations. Remember, this was all like it was all designed for having disk IO of one disk block, or maybe at max two disk blocks for retrieving a record, right? So if I wanted to, if this was in main memory, then and let's say I had to retrieve this particular record, right? So it was easy. But if this itself is long, that you'll have to have additional disk IOs. So that is one. And the second one being that directory expansion operation, it's complicated, right? You see that you replace the directory with a new directory, and then you make the children point to the same bucket which the parent was pointing. It's a convoluted operation. So implementation, even if you set aside the implementation, the execution time increases. Okay. So what kind of queries are best suited for extendable hash, right? So hashing is generally better at retrieving records having a specific value, right? So let's take an example here. So let's say you have student ID, right? And you hash it on student ID. So that's a good way of using extendable hash. And your queries are also such that you ask a query, retrieve all the details of student ID 1000, right? So those kind of queries are very good in extendable hash. So you hash your student file on the student ID, and whenever you have to whenever you have to retrieve the details of a student, you just take the student, go to the bucket address table, and then see which bucket this guy will be sitting in, right? If you have more range queries, like let's say that you have an attribute like salary, right? And you want to uh, and let's say you have hashed all your records on salary, and your typical queries are retrieve all records whose salary is between 50,000 and 60,000. So this kind of range queries, where you try to retrieve all the records within a particular range, that may not be so good with extendable hash. So we'll study another structure. This is called as B plus tree. So for B plus tree, this kind of range queries are usually very fast. We'll see more of that as we go forward. But I think that's all for this video. Make sure that you trace out this example by your own. In fact, try a few more records to make sure you understand it, right? Don't leave any loopholes in your understanding. Okay, thank you.